Every summer, I watch the same thing happen. The temperature climbs past 90 degrees. The English houses on the road and the ones built in the last 40 years pull every window shut and run the air conditioning from June through September. Their electric meters spin, their bills climb, and across the fence line, the Amish farmhouse sits open, every window up, a breeze moving through the rooms. The family eating supper on the porch in the evening cool. I have watched this for 80 years, and I still find it worth explaining because the difference between those two houses is not insulation. It is not window quality. It is not the trees in the yard. The difference is geometry. Specifically, it is the geometry of a porch, its depth, its angle to the sun, its placement on the house, and the way it channels air through a structure the way a riverbank channels water. The Old Order Amish have kept building these porches long after the English stopped, not because they are stubborn, because the porches still work, and once you understand the geometry behind them, you will never look at a house the same way again. Stay with me through this, because the part that surprises most people is not the shade. It is what happens to the air. There was a time when almost every house in rural America had a porch like this. You can see it in the farmhouses built between 1870 and 1920. The wraparound design, the porch running across the front and folding around at least one side, was not decorative, it was the cooling system. Builders in that era understood something about solar geometry and airflow that got quietly set aside when mechanical air conditioning became affordable in the 1950s and 1960s. I grew up around houses built before that shift, and I watched the transition happen in real time. Families I knew tore off their porches to modernize. They poured concrete slabs. They installed window units. They called it progress. And in one generation, the knowledge of why those porches were built the way they were, the specific depths, the specific orientations, the reason they wrapped around and did not just run straight across the front, that knowledge stopped being passed down. The old order kept building them. That is the simple fact. Walk the roads in Lancaster County today. Walk the farm lanes in Holmes County, Ohio. The houses you see, the ones that have been in the same families for 4 and 5 generations, they still have the porches. Not because the Amish are sentimental about old architecture, because the porch still does the job. And they have watched it do the job, summer after summer, across more than a century of observation. What the English forgot, the Amish kept building, and the difference shows up every July. Drop a number in the comments if you grew up in a house with a real porch like this. 1 if yes, 2 if no. I am curious how many of you know this from your own childhood. The reason the porch works is not mysterious, but it is specific, and the specifics are what got lost. It starts with the sun, and it starts with a number. The angle of the summer sun at noon over the American Midwest and Northeast. That number is the foundation of everything the Amish porch is built to do. At solar noon, on the summer solstice, the sun sits at roughly 72 degrees above the horizon across most of Pennsylvania, Ohio, and Indiana, the heart of Old Order Amish country. That number matters more than almost any other number in traditional building. At 72 degrees elevation, a porch roof that extends 6 feet out from the house wall will cast a shadow that falls almost exactly to the base of that wall. The entire wall face, every window on that side of the house, and sits in shade during the hottest hours of the day. Not partial shade, full shade. The sun cannot reach the glass. The wall cannot absorb radiant heat. The room behind that wall stays cool because the heat load never enters. This is not accidental. Experienced Amish builders understood this relationship between roof projection and sun angle well before modern architects gave it a name. Solar shading coefficient. They built the porch depth to match the sun angle at their latitude. 6 feet of projection in Pennsylvania. Sometimes 7 feet in Ohio, where the latitude sits slightly lower and the sun angle at noon is a degree or two higher. The numbers are not identical across every farm, but the principle is consistent. The porch is deep enough to shade the wall completely at peak sun. Now here is where most people stop thinking about it. They understand the shade. They do not think about what the shade does to the air. A shaded wall is a cooler wall. A cooler wall means the air immediately adjacent to that wall, the air sitting in the porch space between the post line and the house, stays cooler than the air in the open yard. And cool air is denser. It sits lower. It creates a pressure differential between the shaded porch zone and the open sun-baked yard. That pressure differential is the beginning of the airflow system. The shade does not just block heat, it creates the conditions for air to move. And that is where the geometry of the wraparound becomes the most important piece of the whole design. A straight porch, one that runs only across the front of the house, creates shade. That is useful, but it does not reliably create airflow. The wraparound porch does something the straight porch cannot. It creates a channel. Think of it this way. When you have a porch running across the south face of the house and then turning the corner to run along the east face, you have created a continuous shaded corridor on two sides of the structure. That corridor behaves like a flume. Air entering the open end of the corridor, typically the east end in the morning when the prevailing breeze in most of the Midwest and Mid-Atlantic runs from the southwest, is funneled along the house wall, accelerated by the narrowing geometry of the channel, and directed toward openings in the house. Those openings are the windows. And in a traditional Amish house, the windows on the porch side are positioned to catch exactly this channeled air. The bottom sash raised, the top sash lowered slightly. This creates a stack effect inside the room, cool air entering low from the porch channel, warm air exhausting high from the upper sash on the opposite wall of the room. The wraparound porch is not just a shading device, it is a wind capture and air direction system. The shade creates the pressure differential. The corner of the wrap focuses the air. The windows harvest it. I have watched this work on still days when you would not think there was enough breeze to feel. The porch channel catches what little movement the air has and concentrates it. Inside the house, you feel it. The rooms on the porch side stay noticeably cooler than the rooms facing away from the porch, even on days when the outside air is barely moving. The corner post is the pivot point of the whole system. Where the two porch sections meet, the air coming along one face meets the structure and redirects. If the corner is open, no wall, just posts and rail, the air continues moving. If the corner is closed off with a wall or screen, the system loses efficiency. The Old Order builders left the corners open. They understood what they were doing, even if they described it in terms of comfort and common sense rather than fluid dynamics. This is the part modern builders forgot. They kept the porch as decoration. They closed the corners. They shortened the depth. And they wondered why it did not cool the house. The shade angle and the wrap geometry do most of the work. But there are two more numbers that the Amish kept consistent across generations of building, and both of them matter. The first is the porch roof pitch. Most of the wraparound porches I have observed on Old Order farms run a shallow pitch, typically a 3-in-12 or 4-in-12 slope. That is 3 or 4 inches of rise for every 12 inches of horizontal run. This is shallower than the main house roof, which typically runs a steeper 8-in-12 or 9-in-12 pitch. The shallow porch pitch is not an accident, and it is not purely aesthetic. A shallow pitch keeps the porch ceiling low, typically 7 to 8 feet above the porch floor. That low ceiling does two things. First, it keeps the shaded air mass close to the floor where people sit. Second, it reduces the volume of air that needs to be cooled by the shade before the porch becomes comfortable. A high cathedral ceiling on a porch wastes the shade. There is too much air volume above head height that the sun can still heat from the sides. The second number is the ceiling height inside the house on the first floor. Traditional Amish farmhouses run 9 feet of ceiling height on the first floor, sometimes 9.5. This is higher than the standard 8-foot ceiling that became the American builder's default after World War II. That extra foot matters because it creates a larger volume of cooler air near the floor, where people live, while allowing warm air to stratify and collect near the ceiling, away from the occupied zone. The 9-foot ceiling also works with the windows. A taller window opening allows more of the warm, stratified air to exit through the upper sash, while cool porch air enters through the lower sash. The stack effect is more pronounced. The air exchange is faster. Put these numbers together: 6-foot porch depth, 72-degree shade angle, 3-in-12 porch roof pitch, 7.5-foot porch ceiling, 9-foot interior ceiling, and you have a system. Not a collection of nice features, a system. Each number supports the others. Change one and you reduce the efficiency of the whole. The Amish did not write these numbers down in a manual. They passed them through building practice. A son watched his father frame the porch. A neighbor watched the depth get set. The numbers traveled through observation, not documentation. And they are still in the porches being built on Old Order farms today. If what you have heard so far has given you that quiet feeling, the feeling of something old clicking into place, leave a like so I know this is landing the way I intend it to. Because what comes next is the part that I find the most remarkable. We have talked about shade and airflow. We have talked about the geometry of the wrap and the numbers behind the roof pitch. But there is a layer underneath all of this that most people never consider. The porch does not just cool the air, it changes the thermal mass of the entire house. And the way the Amish oriented the porch to the compass, which side of the house it wraps and why, is the piece that makes the whole system work across a full 24 hours, not just during the afternoon. If you are the kind of person who wants to understand how these old systems actually functioned, not just the surface, but the engineering underneath, subscribe right here. This is what we do. If you walk the Old Order farms and pay attention, you will notice a pattern in where the porch wraps. It almost always covers the south face of the house, and it almost always turns the corner onto the east face, not the west. This is not coincidence. It is orientation strategy. The south face receives the most direct sun exposure across the full day. Shading the south wall is the highest value use of the porch. A 6-foot projection on the south side, calibrated to the summer sun angle at roughly 40 degrees north latitude, shades that wall completely during the peak heat hours, from about 10 in the morning to 2 in the afternoon. That is the window when solar heat gain through an unshaded south wall is at its most aggressive. The east face wrap serves a different purpose. Morning sun comes from the east. In summer, morning sun is lower in the sky, roughly 45 to 55 degrees above the horizon at 8 or 9 in the morning. A porch on the east face shades the east wall during the morning hours, preventing the house from absorbing heat early in the day before the thermal mass has been fully cooled by the overnight temperature drop. This is the part that surprises people. The porch is not just a defense against the afternoon heat. It is a defense against morning heat loading that would otherwise warm the thermal mass of the walls before the coolest part of the day has finished doing its work. The west face is typically not wrapped, and there is a reason for that too. The west face gets the late afternoon sun, low angle, long exposure. You might think this is where the porch is most needed, but the Amish solution for the west wall is not a porch, it is a tree. A large deciduous shade tree planted to the southwest of the house, positioned to intercept the late afternoon sun. The tree provides shade on the west wall from roughly 3 in the afternoon onward, and unlike a porch, a tree casts shade at a much lower angle, which is exactly what the low western sun requires. The porch handles the high-angle south and east sun. The tree handles the low-angle western sun. Together, they cover the full solar day. 2 tools, 2 different geometries, 1 coordinated system. Here is where the porch system reveals its full depth. Most people think about cooling as a daytime problem. You block the sun during the day, the house stays cool. That is true as far as it goes. But a house is not just air. It is mass. Walls, floors, ceilings, all of that material absorbs heat and releases it slowly. If the walls absorb heat during the day, they release it into the house at night. The rooms stay warm even after the outside air cools down. The Amish porch prevents the walls from absorbing that heat in the first place. A south wall that has been in full shade from 10 in the morning to 4 in the afternoon has absorbed almost no solar heat load. The stone or brick or heavy wood framing of that wall stays at something close to its morning temperature, which, on a typical summer night in Pennsylvania or Ohio, might be 65 to 70 degrees after the overnight cool down. That cool thermal mass becomes an asset in the evening. When the outside air temperature drops after sunset, and in the mid-Atlantic and Midwest, summer nights typically drop to the mid-60s even when days hit the 90s, the homeowner opens the windows fully. The cool night air flows in through the porch channel, through the open windows and across the cool interior walls. The house breathes, the thermal mass absorbs the cool night air. By morning, the walls are cool again, and the cycle repeats. The porch makes this cycle possible by protecting the thermal mass during the day. Without the porch shade, the walls absorb heat all day and release it all night. The house never fully cools. The cycle breaks. I have observed this in the houses I grew up around. The ones with the deep porches, the ones with the south and east faces fully shaded, they were cool by 8 in the morning. Cool in a way that a house without that porch geometry was not. You could feel it when you walked in. The air had a different quality, heavier, quieter. The walls themselves felt cool to the touch. That is thermal mass doing its job, and the porch is what made it possible. Be honest with yourself right now. Have you ever walked into an old house and felt that quality of coolness that you do not feel in a modern home? That is what we are talking about. Leave a comment and tell me where you felt it. The geometry of the porch roof and the orientation of the wrap are the primary system. But there are details in the construction of the porch itself. Details I have observed consistently across the farms I have known that complete the design. The first is the railing. Traditional Amish porch railings are built with wide spacing between the balusters, not the tight 4-inch spacing required by modern building codes for fall protection, which effectively turns the lower half of a porch into a solid wall. The old railings run balusters spaced 8 to 10 inches apart, sometimes wider. The purpose is air passage. The lower zone of the porch, or from the floor to the top rail at about 32 inches, is where the coolest, densest air sits. If you block that zone with a solid wall or tightly spaced balusters, you interrupt the airflow channel at exactly the point where it matters most. The second detail is the porch floor itself. The floors on these porches are laid with a slight gap between the boards, typically an 1/8 to a 1/4 inch. This is partly for drainage. Rain that blows onto the porch needs to drain through the floor rather than pooling, but it also allows a small amount of air to move up from the ground space beneath the porch. The ground under a shaded porch stays significantly cooler than the open yard. I have measured the difference at 10 to 15 degrees on a hot afternoon. That cool ground air seeping up through the floor gaps adds a small but real cooling contribution to the porch air mass. The third detail is the absence of screens on the sides. Many modern porches are screened in, wire mesh on all sides to keep insects out. The old order porches I have observed are almost universally open on the sides, no screens. The reason is airflow resistance. Even a fine wire screen reduces airflow velocity by a measurable amount. In a system that depends on gentle natural air movement, that resistance matters. The Amish manage insects the way their great-grandparents did, with plants, with timing, with the simple fact that a moving air porch is less hospitable to mosquitoes than a still-air screened porch. These are small details, but in a passive cooling system, small details accumulate. The wide railing gaps, the gapped floorboards, the open sides, each one removes a small obstruction from the airflow path. Together they keep the channel clear. The Amish did not calculate airflow resistance coefficients. They built what their fathers built, and their fathers built what worked. Across 2 centuries of observation, the details that reduced comfort got corrected. The details that worked got kept. What remained is a refined system, not designed in a single moment, but evolved across generations of use. I am asked sometimes by neighbors, by people who have watched these farms the way I have, whether any of this can be built today, whether a modern house could use this system. The answer is yes, with specific choices made at the design stage. The first choice is orientation. The house needs to be sited with the long axis running east to west, so the south face is the largest wall face. This is not always possible on a narrow lot, but on any lot, with reasonable flexibility, it is achievable. A house oriented 45 degrees off true south loses a significant portion of the porch's shading efficiency. The geometry stops working cleanly when the wall is not facing the sun directly. The second choice is porch depth. 6 feet is the working minimum for the latitude range of Pennsylvania through Indiana. 7 feet gives more margin. Less than 5.5 feet, and the shade line at peak sun falls short of the house wall. The windows are exposed during the hottest hours. This is the most common mistake I see on modern houses that attempt a porch. They build it 4 feet deep because it looks proportional, and then it does not shade the wall. The third choice is the wrap. A straight porch on the south face alone gives you shade. The east face wrap gives you the airflow channel and the morning heat protection. If you can only build one, build the south face. But if you are building for performance, the wrap is where the system becomes whole. The fourth choice is the ceiling height inside, 9 feet on the first floor. This is not expensive to build. It is a matter of cutting studs to the right length, but it requires the decision to be made before the framing starts. After the fact, it cannot be corrected. The fifth choice is the railing, wide baluster spacing on the lower rail. If local building codes require tighter spacing for fall protection, the lower section of the rail can be left open, the top rail at the standard height with balusters only above 30 inches, leaving the lower zone clear for air passage. This satisfies code and preserves the airflow path. None of this requires unusual materials, no special technology, no mechanical systems. The cost of a properly built wraparound porch on a new house adds perhaps 8 to 12% to the construction cost of the exterior, against a lifetime of reduced cooling loads or Tafka, and in many climates, eliminated air conditioning entirely. That cost recovers quickly. The Old Order Amish did not build these porches to make a statement. They built them because they work. Across 2 centuries of observation, across 8 decades of watching these farms through every summer I can remember, I have not seen a better passive cooling system for this climate. Not a more elegant one. Not a simpler one. The geometry does the work. It has always done the work. Most people just stopped building it. If you know someone building a house, or someone who has always wondered why the old houses stayed cool, send them this video. This is the kind of thing that used to travel from neighbor to neighbor. Now, it travels this way. We are nearly through. If you have stayed with this from the beginning, you have heard something that most people who build houses today have never been told. Not because it is complicated, because it stopped being taught. There is more like this here. Systems that the old order kept building when the English moved on. Water systems, heat systems, food storage methods that outlived the technology that was supposed to replace them. If that kind of depth is what you are looking for, subscribe and you will find it. The last thing I want to leave you with is the simplest observation I can offer. The one that has stayed with me across 80 years of watching these farms work. The house that stays cool without a machine is not a mystery. It is geometry, built once, working continuously, outliving every alternative that was supposed to replace it. Thanks for watching. The end screen has more videos in the same world. Pick whichever video on the end screen calls to you. They come from the same place this one did.